Hey guys, welcome back to another big night within our chapter of rational expressions. And tonight I think is a significant jump up in difficulty. So, we started with simplifying and then we went to multiplying, we went to dividing, and today we've settled on adding. Now, let's say on a scale of 1 to 10, 1 being the easiest thing we've ever done, 10 being the hardest thing we've ever done. I would put simplifying, around a 3. I would put multiplying, dividing around maybe a 4 or 5. These are definitely what we see tonight and tomorrow night are definitely going to be at that 8, 9 level, some of the harder things we do all year. So we're going to do our best to kind of walk right alongside with you here and make this as much as a doable process as we can. So we're focused on adding. And I think, what makes this so challenging is all of a sudden when you're adding fractions, if you recall from your earlier days, the emphasis is on having a common denominator, okay? And so as you kind of get a sneak peek of some of the problems we're going to see later in the video here, you'll notice that the denominators are not the same. And so really our job is to manipulate these fractions and rewrite them so that they do have common denominators so that we can actually go ahead and add them. The one nice thing that we're taking off of our plate tonight is, we're not going to worry about subtracting yet. And so we don't have to worry about distributing that pesky minus negative sign thing. But so first off here, let's just warm up with this example. What if we already do have common denominators? What are the rules for adding fractions if we already have a common denominator? And I think this little definition here is worth its weight in gold, okay? So what we're saying is if you want to add or subtract two rational expressions or two fractions with the same denominator already, we simply add or subtract the numerators and then write that result over the common denominator itself. So what does that look like here? So this is a very minor step, but what I like to do is I like to combine the two fractions, so I'm going to say, let's say we got 4x plus 2 plus the quantity 3x minus 5 all over 6. So I'm doing exactly what we just said. We're simply going to add or subtract the numerators and then write that result over the common denominator, which in this case is a 6. So as I just go ahead and combine like terms, we could combine the 4x and the 3x to make 7x. We'll combine the 2 and the negative 5 to make negative 3 and just put that result over our common denominator, and that's our final answer. So moving on to our next one here, we've got 8a plus 9 plus the quantity 2a minus 3. And I have to confess, I'm just really embarrassed with my handwriting here. So we'll see if I can maybe reposition things here and get it a little more comfortable. So anyway, we're just going to combine like terms again. Combining the 8a and the 2a makes 10a. And then combining the 9 and the negative 3 makes 6. We'll put that all over a minus 4. Now, one thing you do want to kind of be on your toes for is sometimes after you get to this point, there's opportunities to reduce this answer. So we'll go back to our lesson just before Thanksgiving. Can we simplify this singular fraction? So what I'm seeing in that 10a plus 6 is a GCF of 2, leaving me with 5a plus 3. However, in this case, it doesn't lead to any common factors that I can cancel out. So unfortunately, it didn't help me. But so these two answers are equivalent. I prefer this one just because, it shows the thought process of just checking to see if it is simplified. And then we said, yeah, it really is. Okay. So now what happens when the denominators are not the same? What happens when the denominators are not the same? So when they're not the same, we must manipulate them so that they become the same. Okay, because until we get the common denominator, we're going nowhere. So how do we find this common denominator? Basically, in a weird kind of way, we're going to multiply each fraction by a form of 1. Okay, and what do I mean by that? So we're looking at this first example. Maybe this is an example straight out of like your 6th or 7th grade notebook. So we're thinking that I am going to have a common denominator of 15. Now, how do I get there? Well, what I'm going to do is I'm going to multiply this very first fraction by 3 over 3. Okay. And that what I have here in pink is a form of 1, right? And then I'm going to multiply this fraction over here by 5 over 5. And again, what I have here in pink, 5 over 5, is a form of 1. So that's the key. When we manipulate these fractions, we have to make sure we're always multiplying by a form of 1. And once we go ahead and try to simplify that, let's see here. I'll multiply the 3 and the 3 to make 9. Multiply the 3 and the 5 to make 15. 2 and 5 make 10. 3 and 5 make 15. And then we can go ahead and combine the 9 and the 10 to make 19 over 15. And we are done. Okay. So in essence, what you can do is to create that common denominator, you can just basically multiply the two original denominators together to make a common denominator, in that case of 15. So I'm going to try the same approach on this next one. I can't factor x minus 2 any more than it already is, and I can't factor x plus 5 any more than it already is. So just like the last example, I'm going to say that the product of those two denominators is my common denominator itself. So here's what I'm thinking. My common denominator is going to be x minus 2 times x plus 5. And I need to manipulate this and create two new fractions whose denominator is x minus 2, x plus 5. So this first denominator here is missing a factor of x plus 5. And I've got to make sure that I always multiply by a form of 1. Okay. So in essence, I'm going to distribute the 4 to make 4x plus 20. Now over here, this denominator is missing a factor of x minus 2. And I got to multiply the top and the bottom by the same thing so that it's a form of 1. I'm going to go ahead and distribute my 3 to get 3x minus 6. Ooh, baby, we are cooking. We're doing some big time math tonight, huh? All right, so now's the easy part. Let's just combine the numerators together to get 7x plus 14, all right? All over x minus 2, x plus 5. And then check this out. Just when you think this is your final answer, there may be an opportunity to simplify, right? And so what we're going to do is we're going to take out a GCF of 7. And we almost see an opportunity to cancel some factors. But of course, the x plus 2 on top doesn't cancel with the x minus 2 on the bottom. So unfortunately, even though we checked it, we were not able to cancel anything out. All right. So here's our most challenging one tonight for sure. Sometimes these two denominators have factors in common themselves, okay? So what we're saying is what we didn't have in the last one. So for instance, let's say our denominators here, we had a 5 and a 3. The 5 and the 3 had nothing in common, so we just multiplied them together, right? However, in this next example, look at this. My denominators down here are 4 and 6. So option number 1, you could just multiply the 4 and the 6 together and say their product is 24, so the common denominator is going to be 24. Well, what that's going to do in the long run, though, is it's going to create just a little bit of extra work because although 24 is a common denominator, it's not what? It's not the least common denominator. So that's what we're in search of. We're in search of the least common denominator, emphasis on least, because that's going to create the least amount of work for us to do, right? So here's what we want to do here. I want you to factor the 4 and the 6. What do I mean by that? So 4 is equivalent to 2 times 2. 6 is equivalent to 2 times 3. All right. So what we're missing here, I'm thinking this denominator right here is missing a factor of 3, and this denominator is missing a factor of 2. So I'm going to multiply the first one here by 3 over 3. And the second one by 2 over 2. So notice the first thing I'm doing is I'm saying, okay, what is this denominator missing, right? The first one was missing a factor. This guy was missing a factor of 3, so that's what I multiplied it by. This one was missing a factor of 2, so that's what I multiplied it by. And what that's going to do, I'll go back to the black pen here. So multiply the 3 and the 3 to make 9, and then multiply the 3 and the 4 to make 12, right? So we're saying 12 is my common denominator. 5 times 2 makes 10. 6 times 2 makes 12. So we're saying you could have used 24, but 12 is a more efficient way about going about this problem. And so once I combine the 9 and the 10, we'll say, okay, 19 over 12 is my final sum. All right. So the good news is on this next example, at least the denominators are factored. All right. They're already factored. That's worth drawing a smiley face for, isn't it? Let's be thankful for denominators that are already factored for us. That's very, very kind. All right, so here's what I got cooking. I'm looking at this first one, and I see a factor of x plus 2, and I see a factor of x minus 1. But when I take a peek at this other denominator over here, I say, you know what? This first one's missing. What's it missing? It's missing a factor of x minus 4. So I'm thinking to myself, I got to multiply the top and the bottom by a factor of x minus 4. And then the second denominator here, it's got the x minus 1. It's got the x minus 4, but what is it missing? It's missing a factor of x plus 2. So we're going to multiply the top and the bottom by x plus 2. Now this blue pen isn't working real nice, is it? So maybe we'll switch to something that's a little more visible. So I've got an x minus 4. I'm going to distribute the 5 here to make 5x minus 20. And look at this denominator. It's going to be my x minus 4, and then the x plus 2 and the x minus 1. Okay, plus. Okay, now we have an x plus 2 over here, and I've got to distribute the 6 to make 6x plus 12 all over the x minus 1, the x minus 4. And it doesn't really matter what order you put these three factors in the denominator, as long as you got all three. So the hard part is done. And really all you got left to do is to combine like terms. We're going to combine this 5x with the 6x to make 11x. We'll combine the negative 20 with the 12 to make negative 8. So let's see what this looks like. It looks like 11x minus 8 all over our common denominator. Whew. Some big time math we got cooking here. Some big time math. I tell you what, guys, we can do it. We can do it. And that's the last example I've got for you tonight. So, this is hopefully, one way I'm kind of thinking about breaking these lessons up into is, let's think, we've got our easy intro caliber questions, we've got our medium, and then we got our harder questions. What I'm hoping to do in these videos is to, give you a taste of that easy intro one. I'm going to give you the medium ones like we just did here, this last one. And then when we join together as a class tomorrow, I'm going to, throw a harder one or two at you. We'll talk through them, and then we'll be ready to jump into that homework together in class. All right. So hope this made a little bit of sense, and we'll keep building on it tomorrow.